Alright, I think we are live. So let me just fire this all up. Okay. Yeah. And I think we're good to go. So, hey, this is Kenneth. Welcome to another live stream. Hanging out. Today we are going to be working more on this Raspberry Pi sensor hat. So, the summary of the project is a... Let me make sure I got this all pulled up right. The project is we want to have a hat that sits on top of the Raspberry Pi with the various air, mainly like air quality sensors, a temperature sensor, etc., etc. And then so far, I did the schematic capture several months ago off screen. Last week, I kind of did the real rough board layout, which we can see here. Right, and so I've done the board outline to put you on top of the Raspberry Pi, and most of the component, kind of the rough component placement. We're going to see how much of that actually survives, but the main thing is actually routing all the traces, as well as mainly the silk screen. Right, the silk screen is going to be the hard part at this point because we want this thing to be a pretty we want this thing to be a pretty friendly board to be able to just pick up and start stuffing. Right, obviously I've got through-hole components on this exclusively, and etc. So let me make sure this stuff's all cooperating. I'm getting some warnings from the live stream. So we want to... Alright, so we've got people in the chat saying that I'm live. That's reassuring. And then it's saying that my resolution's bad, which is probably just because my internet sucks. So yeah, I think we're gonna stick with that. We're gonna just power on through. We got that. This whole live streaming thing's hard. Hope you guys don't mind the awkward silences as I'm sitting here trying to deal with all of you being actual people, as well as make sure that this thing's actually going out. So there we go. All right, so that's what we're gonna do. That being said, it is an evening, so the first thing we're actually going to do is we are going to crack open a bottle of wine, just to make it that sort of show tonight, because we're going to try something new. Yeah, I think the main thing this YouTube's giving me a warning about, like the stream resolution is not a full 1080. So you guys are going to be able to enjoy this board layout in fuzziness, but I don't have an amazing internet connection, and monitors have been changing faster than live streams, because I think I've gone through about 4 different monitors in the last week now at this point, because I'm too cheap to actually buy new monitors, and so all of my monitors are secondhand. And it turns out some of them only last for a day or two, and then I realized why they were on the e-waste pile. So everything's pretty much a hot mess. Turns out being a YouTuber is hard and takes quite a bit of effort. So, so the plan tonight is we're going to be laying out this board, kind of looking at it from how I had it placed last time. Obviously, all the nice corner roundings and stuff need to get fixed. So that's no bueno. We've got the issue that, I mean, all the silk screens and stuff are a hot mess. The bill of materials is a hot mess. I've totally lost track of where, right? Because like several of these, like the GPS and the BME 280. All these breakout boards are things I found on eBay, and I've totally lost track of where those are from. So we're going to have to hunt those down again. And then I also realize now that I had originally envisioned this ADC to be... look at that. There we go. I originally envisioned this ADC to be like right on top of the header, which was going to be much more forgiving as far as the analog power supplies on it. Now that I realize that it's all the way on the far end of everything, we're probably going to want to try and get some bypassing on there as well. Tonight's bottle of choice is a Barefoot Cabernet Sauvignon with out a year on it. Really? That bodes well. I have good taste in wine. So we're probably going to actually want to go back to the schematic and change that a bit to give some sort of bypass in here. Not because I'm really that concerned about it, but because it's noise on your ADC lines is one of those things that is just going to kind of chronically be a bit of a nuisance, and you're never going to quite know why it sucks, but it's just a good thing. Is the board going to be fine without it? Of course it's going to be fine without it. It's like, these are all DC signals, but we're going to do the best we can. So, on that note, let's get right into it. So we first want to go back to the schematic. And the source of concern is this ADC doesn't have any bypassing on it. It also still has two unconnected channels, which bother me a little bit. And so I suspect that it, for the sake of goofing around with this first, iteration of it, I think we might do the same trick as the Knox preheat pin down here on the 4514 sensor. Is that I think we'll break it out as a single solder pad, just so that if we later just come up with some use for this extra, these extra two ADC channels, we can at least bodge a wire onto the board relatively easy, right? And like many things in schematic board layout, the trick is primarily to give yourself get out of jail free cards. And so we're going to just drop two of these on there like that. And then we're going to fix the value. This is going to be ADC 1. Yeah. And then ADC 4. This board hasn't even, like, we're not even on the first iteration of it yet, and this board already has weird legacy stuff going on because it's, like I explained last time, the original source of this project is the fact that there is the AirPi project that did their board layout in Eagle, and then I get the sense like the project's kind of dead, and so this is us essentially porting the whole project over to KiCad, dumping the sensors that we weren't specifically interested in, and then just redoing it. And so in an ideal world, I would, have designed all of this myself in some opinionated manner, but it was a lot easier to just copy their schematic over, so that's what happened here. Alright, so we got those. We're going to need to annotate them. Ready, set, go. So annotation gives you your reference designators on stuff that's undesignated. So since these are jumpers, they're just annotated as J4 and J5. And then we wanted a bypass capacitor here, which I think will be easier to lay out as just a floating 3.3 volt to ground component somewhere else, like here. So we're going to want a capacitor, unpolarized. Yeah, I mean, we're probably only talking about, because, I mean, this ADC isn't going to be taking much current, and it's going to be a relatively slow digital signal. So really, realistically, since we're already operating off of a buffered rail, screw it, let's give it both. Let's give it a 0.1 microfarad and a like a 10 microfarad. So we've got those. Another annoying bug of KiCad, the fact that when your junction is on a pin, it doesn't put a junction dot like you'd expect if our junction was there, right? That's totally as expected, but if it doesn't show up, if you do it on the pin, which that should be fine, right? Value, so this is going to be a 0.1 microfarad, and then this is going to be a 10 microfarad. All right, and so you want, there's all sorts of arguments for bypassing about how you want one capacitor value everywhere or two capacitor values that are a couple orders of magnitude apart, so that these two capacitors will have different self-resonant frequencies. So if you happen to have noise at the self-resonant frequency of the ceramic capacitor, your electrolytic will be effective at that frequency range. Again, since all we're doing is we're operating a single SPI ADC onto the Raspberry Pi, I'm not too concerned. But that's what we're doing here. So we're going to need to annotate those as well, which hopefully are going to be C1 and C2 because those are the only ones we've got. These are going to be, these are through-hole components, and I think this is the first through-hole board I've done in a long time, so we are now actually going to need to figure out what footprint to give these. I own almost none of this, and by this I mean through-hole capacitors. I haven't done any through-hole projects in a long time, so we're actually going to need to figure out what package we're going to want to specify for this. digikey.com. The way to do this is to go to DigiKey and start puttering around. So, products, view all, passives, power supply, potentiometers, capacitors. Oh, okay, so it's its own category. So we're going to want aluminum electrolytic capacitors, and we're going to want ceramic capacitors. Let's look for C1 first, which is a 0.1 microfarad ceramic capacitor. So we're going to want 0.1 microfarad. We're going to want through hole. What does that give us? What? 1,458. We're also going to want it to be in stock. We're also only going to want it, we're going to want to be able to order it in quantities of 10. This feels kind of nice because it'll give you the pricing in whatever quantity you give it in, and it'll also ensure that it only offers you components that you can source in that quantity, right? And so I typically go, well, I'm not going to buy one capacitor for a project. I'm going to buy 10 or 100 for generic useful stuff like a 330 ohm resistor or a 0.1 microfarad capacitor. I'd actually probably buy 1,000, but I'm not going to expect any normal people to want to source 1,000 of a passive component. So let's say 10. What this is going to exclude is it's going to exclude your tape and reel and full packaged cases of a component. So like this first component here is actually a perfect example. The DigiKey part number is effectively the same. The vendor manufacturer part number is actually, oh gosh, you can't see that. My face is in the way. Like I was saying, oh, is this screen getting cut off? Oh shoot, the screen is getting cut off. All right, we're gonna have to play with that a little bit. But first, let's talk about this. So we have these first two components are the same manufacturer part number. It's a Vichy capacitor. There's 112,000 available, except that one of them is only available in quantities of 4,000, where the other one's available in quantities of 1, because it's an entire reel of tape of the component versus a cut tape. So we only are interested in the cut tape one, so we're going to say 10 there, which eliminates the option of buying a reel of 4,000 because you can't get a price for 10 components packaged in units of 4,000. Right, so we got that. We want to filter on in stock, and there's that. But we apparently have the issue that this screen is too large. So how's that? Yeah, now you can actually see like the bottom of the screen and everything. Okay, cool. All right, like I said, we've been swapping monitors more often than live streams. Today's monitor of choice is a lovely 28-inch ViewSonic, only 1950 by 1080. We will see how long this one survives, seeing as how the last one lasted for about a day and a half, and the one before that would take about 15 minutes to turn on. Not my proudest moment. Nice things is kind of just not my thing. I don't tend to do well with nice things. Okay, so yes, all right. So now we're down to, we are looking for capacitors that are 0.1 microfarad. We're looking for capacitors that are through hole and not chassis mount or panel mount, or what? Chassis mount, surface mount, anything like that. We want only capacitors that are in stock in DigiKey, which means that they're pretty normal components and they're something that you can source. And we want 10 of them. So the big question still is pretty much the main question is what lead spacing do they have? Right, because this one here is probably going to be 0.1 inches. Size, dimension, lead spacing 2.5 millimeters, about 0.1 inch. So let's just sort by price. And that actually is the cheapest one. That's actually kind of nice because I do kind of like these 100 thou, or in this case I guess 95 thou capacitors. Our two options are VF versus VE. So what's the difference here? They're both Wi-Fi V. They're both 50 volts versus 25 volts. Well, we're putting 3.3 volts on it, and so even, yeah, 25 volts will still be okay. The Wi-Fi V is your material type, so this is like the X5R and X7R, or Wi-Fi V. Wi-Fi V, if I'm remembering correctly, is about the worst material you can get, so which is reasonable since we're buying the cheapest capacitor we can find here. Or we could go up to X7R. Yeah, let's say that I actually don't want to use Y5V material. And so I want my lead spacing to be something around 0.1 inches because that'll make board space a little bit easier. And then let's actually specify X7R just so we have a nicer capacitor. Not that it really matters because obviously if we're going to use something real standard like 100 thou as our lead spacing, you're going to pretty much be able to source capacitors in what you want. Yeah, so we're talking about 13 cents. So there's our component. There's a manufacturer lead time of 8 weeks, which is pretty standard. Whenever I get custom capacitors, you're talking about 8 to 10 weeks. 50 volts, which is overkill. So price breaks of 20 cents, 13, and 6. So I would recommend that you buy 100 of these because 0.1 microfarad capacitors is one of the things that's pretty useful. 10%, sure. So we're going to say that that's what we want. And we're going to be much more careful today about not shooting ourselves in the foot as far as keeping track of our parts. So we're going to start a BOM file. Is this a good way to do bill of materials? No, this is a terrible way to do bill of materials. Is there a better way to do it? Probably. Is it straightforward in KiCad? No. But the main thing is that we have decided that we are going to use 100 thou capacitors. So footprint, assign footprint. Oh, capacitors through hole. Axial, radial, disc, rectangular, dear God. What, we're looking for something that's 2.5 millimeters? Nope, 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 nope. Okay, okay, so what, the pin to pin is 2.5? Yes. Yes. So that's the question, what width do we want for the courtyard? That's a tough and deep question. YOLO bomb. Exactly, right? We got our priorities straight on that one. Data sheet. What the hell? No data sheet? Data sheet. Fantastic. So we're looking for exactly how big of a courtyard we want. That data sheet's not at all useful. K-series. So we're looking at a K10. Dimensions. They're all the same. Size code. T 2.3. Right, so we're trying to decide which of these footprints to use between this one, this one, this one, and this one, which all have the same pin spacing, but have different courtyards as far as how big the actual component is. And so the deep question was, is it a 2.1 millimeter package wide, or is it a 2.6 millimeter package width? of course, what is it? We're looking at the T dimension here for the size code 10. T max is 2.3, which is between 2.1 and 2.6. So, not that I'm going to actually probably push... I'm not actually going to push the capacitor component that close to anything else, probably. But we'll just go with 2.6 so we have extra space. Well, it's assigned. There. That component is fully spec'd out. Now we got to do the same for C2. So let's find our... Let's see, let's find all of our browser windows again. Sorry, I'm trying to deal with Livestream stuff again here. Okay, there we go. All right, cool. So, we've got that one picked out. All right, so now we're back to electrolytics. So, we're looking for a 10 microfarad through-hole electrolytic in a relatively small package that can handle a whole whopping 3.3 volts. Match package type, radial disc, etc. I mean, I guess I probably could. I don't really care. So let's... All I really care about is the spacing between the two holes and the courtyard around it to keep me from colliding this component into another one. So they do technically have different footprints here for disc versus rectangular versus axial, but in the end they all have 2 holes on the board, 2 leads, and some sort of courtyard around them. So I'm more looking at it from a perspective of what it looks like here versus what it was actually designed for. Because obviously none of this was actually designed for the component we're using. So in an ideal case, I would be actually laying out... Did that not change? That changed. Ideally, we would be laying out our own specific footprint for the component we're using, but I'm saying that this is close enough because there's 2 holes in the right place. So, doing that whole exercise again. So we want stuff that is in stock. We want stuff that is, I don't know, around 10 microfarad. You could certainly talk me into something going up, you know, to 47. So let's do a shift click on that. I don't care about the tolerance. Pretty much any of these voltages are going to be good enough. ESR is going to kind of mostly fall out of pricing. I'm not too concerned about lifetime because we're not stressing it, and this thing's... I guess it is conceivably going to be somewhere hot, but for prototypes... I'm going to say that if you want this thing to survive a long time in some sort of actual stressful environment, you either don't put the aluminum capacitor in there, or if it fails, you just hope that the rest of your Raspberry Pi is fine, which it probably would be. And then lastly, I think the only thing I care about is its through hole. Apply filters. Leave us with 4,000. I want to be able to buy just 10 of these. What is the cheapest one you have got? Ah, bright red. That's always nice. So, 10 microfarad, 20%, 16 volt. That's exactly what we're hoping for. 2,000 hours, that's decent. Temperature ranges that are well in excess of the Raspberry Pi. Through-hole radial cam. Bam. Tell me your secrets, aluminum electrolytic. Okay. 2,000 hours. Polar, ripple current, 35 milliamps. I don't know if 35 milliamps is enough, guys, for this ADC. It's enough. Lead spacing. Wow, 2 millimeter. This thing's smaller than the ceramic, lead spacing wise, and it's 5 millimeters in diameter. Sure, I like it. Let's take it. C2. Manufacturer part number. I guess it probably would have been smart to have saved this as a worth with the DigiKey part number. Sorry about that. Alright, so the magic values that we need to remember are A. I mean, B is going to be somewhat important as far as what our drill size is. But then D. Right, so D is the size that we want for the silk screen in the courtyard on the board. That's going to be 5 millimeters. A is our pin spacing, which again is 2, right? And so this is me double checking DigiKey's catalog to make sure that they've got the specs right out of this data sheet. If this data sheet and DigiKey's catalog were to not agree with each other, I would delete the line and we would find a new component, because I just don't want to deal with that nonsense. But I think we're going to be okay. So here we edit this capacitor, assign footprint, capacitor through hole. Now we're on the radials. We want a diameter 5 millimeters. Oh, yeah, look at that. There we go. I think that's it. So capacitor polarized, radial, diameter 5 millimeters, pins 2 millimeters. That's what I want. Done. Excellent. All right, so here's our 2 bypass capacitors done. So those are going to go immediately next to the ADC. We've got 2 little breakouts there, which is fine, considering that we're not using those pins, which are ironically channel 0, the first channel, and channel 4. The fact that we're using 0 index on the component and 1 index out here is something that we're just going to let go. We're going to let it go, just like the song. And it's conceivable that we might then be done. Yeah. We still need to figure out these boards. All right. So let's go to eBay. And find some 6-pin breakout boards for this thing. Look at that. All right. That looks like the same thing. So pin 1, VCC, pin 2 is ground, pin 3, serial clock, pin 4, serial data, 5, CSB, 6, SDO. So it seems like in the board outline, which ideally this would be a footprint, but you know, not happening. VCC pin 1 is that one, right? It's going to be that one right there, and then it goes this way. So it's kind of like a dip package. So we want to generate our net, run it out to here, import our net. So BME 280, if this is pin 1, it's going this way, which I'm not convinced is how, yeah. Depends if we want it to hang off or stay in. I think if these breakout boards turn in, I think the only one we really want to hang off is, I mean, yeah, we're going to want the GPS to hang off the board, mainly because we're going to have the RTC in the board, although there's nothing keeping us from putting the GPS like here. Alright, so the RTC hangs out here, GPS hangs out there, maybe LEDs get shoved down a little bit, have everything tend to stay inside the board. Yeah, that's pretty reasonable. So I guess our policy is going to be keep stuff facing inward. And then again, we're not doing courtyard here just because I'm lazy more than anything else, right? Because this really should have a courtyard on it. It really should, but we're just going to try and remember it. Have this laid down, maybe put this here. And those will just get moved wherever. Something like that. Alright, so BME, we'll just go there. Mix 45, 15. Oh, that thing's long. Right, that thing is long. Oh, what? 1, 2, 3, 4, 5. So that's about ½ an inch wide. That's about a ½ inch. So that's maybe 7/8 long. Where does 7/8 put us on this board? Raspberry Pi, measuring it. A little bit over halfway. Up to about there. What the hell? We put the GPS back here. Yeah. VCC, ground, red, Nox, pre. I'm just going to go that way. Alright, so I think that's oriented correctly. I don't think these pin spacings are right, but I'm okay with that. Give ourselves a little bit more breathing room there. And then, so we've checked that one, we've checked that one. The GPS needs to still get validated. So I'm looking for a 5-pin GPS receiver. Oh boy, whichever one was cheap last month isn't popular this month. Let's see what we got. We got VCC, ground, TX, RX, pulse per second. Well, that's slightly concerning. So there's the module I was planning on using, which is now rotated, but it's got VCC, ground, RX, TX pulse per second, and I've got VCC, ground, TX, RX pulse per second. What is the chances I've got mine swapped versus they're talking about on the slave device versus... Alright, I mean, how are they're probably matching... Oh, I matched my TX to TX? I did. Oh, no, that's the net name, right, because this isn't a component. This is the Raspberry Pi TX, which goes to the RX, which is the middle pin. Yeah, and then the Raspberry Pi RX, which is coming from the GPS transmit. Okay, we are actually fine. That's correct. And then we've now got that there, and so the GPS goes that way. So if I were to, on Courtyard, draw a line out this way. Oh boy, let's maybe not rough it in that much. That one goes in, that one goes in, that one goes in. What are the chances that GPS interferes with that header? Pretty good. put the header there, and let's put the capacitor there. That's just getting worse and worse. We don't want that there, we want that like over here. This might be more one of those more lean it down sort of capacitors. Or like an optionally populated sort of capacitor. Or you don't really need it sort of capacitor. I'm just trying to imagine where I want this thing to sit on the board. And that might be okay if I put the put the ceramic out of the way. Up. Oh yeah, let's do this. Yeah, I like that. Right? Let's give myself a finer grid for just a second. Like so. Okay, so we've got the GPS, which is definitely going off that way, the RTC hat, which sits in this way, the BME 280 sensor board, which comes in this way, the Mix 4514 breakout, which comes in this way. We've got the TGS 2600, which just sits there. And I think that's just about it. So I think if we were feeling lucky, which I think we are, this would be the moment that we make this stuff happen. So that board outline's probably fine. Am I okay with a 10 thou trace and everything just to be lazy? Eh. What the hell? Yeah, so let's just jump in right into it. That grid isn't going to do us any good. That grid isn't going to do us any good either. That makes it pretty obvious. I don't know how to do the push and shove routing in KiCad. How's that? So worst case, if we really did goof on RX versus TX, we could scrape the wires here, and kind of bodge fixing it. So it is salvageable at that point at least. And pulse per second. Got those. See, now this is where this is where it would be nice if I really knew how to drive this tool, because you could set up, you can put like power rails in a different category so that they get routed, automatically get routed with a different trace thickness, right? Because I think we really do want to have a different trace thickness for our 3.3 volt rails. Oh boy. Sine rules? Yeah. So this is a 10 thou. So how about a 25 thou? Except it's in metric. Yeah. Right. 20 thou? I don't know, we could really go wild and we could like add something really up there. Dang, son. Dang. And grounds will hopefully kind of more or less take care of themselves. Except for that one. We may be in trouble on that one. Okay, we don't want to route this one on the top. Maybe we do want to route this one on the top. No, I don't really want to route this one on the top. I want to route those first. Tell you what, we're gonna rip some of these up. I want to route these 3 ADC lines to the voltage dividers. How do you rip up? Good enough. The grids are 20 thou. Yeah, let's leave them like that. That one, that one. Right, I'm writing these things like they're freaking like DDR lines or something, but they really aren't. Like these are DC inputs to an ADC. So if it seems like I'm stressing out about this too much, that's because I am. We don't need to worry about cutting these off because they're ground, and so since the bottom of my board is going to be a ground pour, those will take care of themselves, like so. Fantastic. Grounds will take care of themselves, right? Because each one of these pairs is a voltage divider here, and then those just need to get routed out to that controller, while the SPI stuff will get swirled through there somehow. All right, then we just need to figure out how to do power. Kind of want to do that. Is that wrong? Let's do that. And so now, when I route this one over here, and then jump under, that won't be too terrible. As far as what it breaks up. Right, so this is real nice because now filtering for this, which is what we're concerned about, your current path in from the controller has to essentially tag off of, you know, both of these capacitors real closely. Well, that is kind of silly there. Let's, nope. Like that. It's good enough. Okay. Is that really all of my 3.3 volt? No. I need to get to there. That sucks. Oh, man. Compromises are going to be made on that one. What are board edges for, other than just cheating? Yeah, it's like I planned it that way. Okay. Ourselves back on a 20 mil ring. Yep. Like so. I'm not going to be able to fit that one through here, am I? Well, that's just disappointing. trying to visualize how I want to snake these various signals through. Nope. Oh god. Nope. Have to be real careful to have the mouse exactly where you want it as you're doing the vias. Yep. Okay with that. Hopefully by managing to keep these all, yeah, except for that one. I was going to say, I was kind of hoping I could keep these all on the top, so I have a relatively unadulterated ground plane. Mainly it's a get out of jail free card for once I get kind of in a bind, like this LED right here. That LED is really kind of an inconvenient spot. So we're going to get this as close as possible and then jump down onto the ground line. Right, because this one then is going to come over this way and somehow get to that LED. Right, we'll figure that out later. Give me my 20 thou grid back. No. God, no. 20. For the sake of nice, pleasing symmetry, we're going to run that like that. And then, on the finer resolution, like so. Pad near pads, I'm okay with that, right? Yeah. So, I'm just doing a quick DRC check just to sanity check everything I've got so far. Yeah, the main DRC fail is actually on these footprints. I really think I like these footprints. I really like them. They're the kind of style of footprint that I like using. But you'll notice there's 5 DRC violations on it, and that's because this hole here interferes with these 4 holes, and each of these holes interfere with this hole. The reason these 4 holes don't interfere with the other ones is because the DRC check is from the top left down, and so these are flagged and these are okay. But yes, this footprint on its own already violates DRC. We're going to ignore it because I'm okay with that. That right there is kind of nasty. Oh god, that wasn't what I wanted to do at all. Can I just move it? Not that I think this is any better. You're not going to notice the angle difference. It totally looks like a 45 right there. I don't know what you're talking about. Alright, I think that part's taken care of. Those are taken care of. I think these will happen on the bottom side. That'll definitely happen on the bottom side. Okay. Well, that's probably not what I'm going to want. Is this via is going to need to probably move up or down somewhere along here, depending on exactly what side I want to route any stuff underneath this IC elsewise. But I'm foreseeing that needing to move later, but we'll deal with that when we come to it. Okay, yeah, that via is definitely not going to need to move. Seeing how, yeah, the rest of these lines are definitely boxing us in right away. So definitely not needing to go anywhere. Yep. Knox and red. Not that one. This one's GGS, which is all the way at the top. Dang it. That wasn't very smart of me at all. One, two, three, four. Because I think that's the leads line spacing we're generally going with. Like so. Alright, so we got those. Alright, so we have achieved something. This J5 for the spare ADC channel, that's obviously going to need to go underneath those, so that'll, I guess this one's actually probably pretty well committed at this point to be right up until there on the top side, and then it'll go underneath. So there's that one. TGS, I guess this one actually could, watch this, this is going to be super awesome. Alright, so I'm going to make space here without obliterating that silk screen. I'm going to take this one on the top side, run it down there. Bring it back up. And then run it just like it's the next one in the party, which it really kind of is. You don't like it. One, two, three, four. Via. Via. All right, let's commit to that much. Then we can run the rest of it like that. Then we can try and move this via as close back to it as possible. Yeah, so it doesn't like that one. Yeah, okay, I see it. You actually can't see it because my head's in the way. But there's an airtight via near track, so that's as close as we can get. Remember, the main thing is this J5 actually probably is going to get cut off, so we'll need to fix that a little bit. But that is beautiful, right? We got this nice even spacing as this stuff all just lines up. We haven't broken up the ground plane that much because we just have that one little jumper. This point here is going to be real easy because the pre just gets run over to this J2, which is probably garbage. This I square C line is going to get exciting. And this is all dead space in here anyways, right? So how about we use it as a nice, comfortable 1, 2, 3, 4. One, two, 1, 2, 3, 4. All we need to do is get them yeah, that'll work, because now I can take this one, take it under, like so. Whew. That was exciting, wasn't it? We're making some good progress here, though. Okay. Again, we're ignoring the grounds, because those will pretty much happen on their own. We've got a 5-volt rail that I've kind of been ignoring. And we've got some resistors. So I'm just tracing out kind of what the strategy should be on these 5-volt rails. I think the biggest inconvenience is the fact that I've kind of got these cornered in up here. Is I'm going to have to really squeeze these through between the header and these, which presumably they did here just by a pour, which actually you probably can't see. So what, if I try and use 30 thou, yeah, it's not going to be, it's too big. Oh, I also really boxed myself in because I got my TX and RX lines there. Piss. What's a 5-volt rail among friends? Alright, so we're going to take the 5-volt rail out and around. Again, we're kind of keeping these power rails that have to be on the bottom out on the edge. This ground will hopefully pick itself up from the top. Just gets worse and worse all the time. Guess I probably can now beef this stuff up. Excuse me. Okay, so there's my 5-volt rail. From here, I need to get over to there. So on the bottom copper, if I were to go opposite of the 3.3 volt rail, ignoring the fact that I did it on a different grid, which really makes me not want to do that one like that, but like that. Perfect. Right, and then this will get picked up on the top side pour onto those, which will stitch you down onto the bottom side pour, which will come back out. So I think my grounds are still solid. Not that this mounting hole really needs to be grounded regardless. Notifications on Twitter. Nothing important. Oh, gone. Okay, I really hope that didn't kill YouTube. Can someone reassure me that this is still alive? Because I think I just closed on my windows in my browser. Let's see. This is gonna play an ad. All right, but cool. All right, yeah, I think it's still live. All right, cool, perfect. Okay, we're getting close. We are getting close. All right, we got the 5 rail out to there. I probably wanted to do the same thing again, didn't I? Yep, I really think I did. Okay. So, yeah, I think I'm literally just gonna... Thank you, Ed. Thank you for the confirmation that I didn't just manage to bork the live stream. Yeah, I think we're just gonna like that. Boom. Then again, I think we're gonna delete that one and aesthetically drop it right onto there. All right, so we've got the mix 5 volt, the accessory connector 5 volt, and the TGS 2600 5 volt. I'm not seeing anything that isn't a ground. Oh, yeah, we got one here. Nope. One, two, three, four. Oh. Yeah, let's just run like that. We got that one. We got grounds, we got grounds, we got grounds, we got grounds. Ground, 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 ground. 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 Ah, LEDs. We forgot the LEDs. Okay, so on the bottom side, we're going to run this one out to there. So those are 2 user indicator LEDs. For all good they are. It was just a hot mess of grounds. Ah, there's a 3.3 volt down here. Why would I do that to myself? I don't want anything to do with trying to route that 3.3 volt right there on pin number 17. That just seems silly to me. Why? I guess it's good to have had that originally because it means that when I was looking at the board I'd have options. I don't think we need it. We're just going to connect from there. And then we're going to say that we're not connecting that one. We don't need to connect 2 3.3 volt rails because we already have one. despite the saying of 2 is 1 and 1 is none, 1 is in fact 1, and 1 is good enough. 1 is done. Generate. Generate the netlist. Switch back over to PCB. Pull in netlist. Footprint selection, reference, exchange footprint. Only way of changing footprints. Great. All right. I like it. I am becoming increasingly suspicious that all we are short is a ground pour. That's what, 58, I think. So I don't think there's going to be any grid here that's going to be the right. Graphic not allowed on copper layers. Add filled zone. Is that what I'm looking for? Ground, top copper, go. Add filled zone. Ground, back copper. Clearance, minimum, thermal relief. Oh, there's a through-hole thermal. I don't know what that means. Let's pour that. Processed. Top view. How do pour happen? Add filled zones and then show something. Trying to, you know, check my work on this ground pour, guys. You want to, like, show it to me somehow? Show tracks in outline mode. That's kind of cute. Not what I want. Ah, there we go. I had to report it. And it has not quite achieved what we hoped for. Track near pad. Did any of these connect? They did not. So are you telling me that this is so broken that it won't even let me ground it? Nice. That's just nice. Alright, well, it looks like we're going back to this one, and we're losing the ground connections on the mounting holes, because for some reason it seems like these mounting holes with the DRC errors can't actually connect to a net. Alright, so this is complaining about our powers don't seem to be driven from anywhere, which is correct. Because I'm just running them from a generic, I'm just using a generic 40-pin header here for the Raspberry Pi header, which has the disadvantage that like the pins that happen to be powers aren't set as power outs, and so it seems like there's no actual supply on the rail. But the problem is, since there's like two 5-volt pins, if I were to set them both as power out, I'd get a DRC error because I have more than one power supply driving the same rail. So there isn't really any winning as far as like these DRC errors that we're seeing. So that in itself isn't enough motivation for me to try and actually fix the try and create a component to fix that DRC error. DRC, pad near pad, times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Well, there we go. I think I just laid down all my copper. So obviously I didn't do an absolute perfect job on the ground because there's a few kind of openy spots around here, which if we were in any other CAD program, I'd just drop some vias in here, really just to pour the copper in so it looks pretty and doesn't have like a big section with a different shade to it. That being said, this is KiCad, which doesn't support naked vias. That's just not a thing in this software, and so I'm not going to bother. So obviously I haven't done anything on the silkscreen yet, and so that would need to still happen. But just for curiosity's sake at this point, I would be interested in seeing what Osh Park thinks of this current board design. So we want to go in here. So definitely not going to order this because it's silkscreen wise not even started. I want to make sure that Osh Park can just like render my board outlines correctly and everything. Redrawing your fill zones. Please verify any copper pores. Oh. Of course, Chrome, in its infinite wisdom, has decided that my middle name apparently is single, thanks to some dating website, which is a little bit horrific. Isn't working. No. Come on. At some point, some dating website or something I was signing up for decided that my their website's dead. Decided my middle name was single, and this has actually happened several times. I've accidentally form-filled stuff for like RSVPs for parties. Yeah, their website's borked. Okay, well, it kind of looked okay. I've accidentally RSVP'd for like parties on like, Evite and stuff as Kenneth Single Finnegan, which is hilarious. But my middle name is in fact not single, despite the fact that I am in fact single. But so we got the copper. This stream's going on for more than an hour and a half, so I think we're going to break this up into a third stream some other evening, in which I'm going to fix all the silk screen on here, right? Because we're going to put my name and put the URL somewhere for the project. We're going to want to put some artwork over here. We're going to want to fix all of these labels. We're going to want to maybe indicate some orientations, all of that hot stuff. But other than that, thanks for watching. I hope you enjoyed it and or learned something, and I shall see you next time. And then we're going to stop the